Hey everyone, so what if I told you that you could actually recreate one of the most fundamental forces in the entire universe right there on your kitchen counter? It sounds a little out there, I know. But today we're going to dive into how the simple act of stirring a glass of water can generate a force that looks, and amazingly acts, just like gravity.
So, let's just get right to it. Can you really create a kind of artificial gravity inside a simple glass of water? The answer is a definite and kind of mind-bending yes, but you have to do it in a very, very specific way. So let's break down exactly how this incredible illusion works.
All right, to get our heads around this, we have to start with the absolute basics, the physics of a spin. This is a force we've all felt, right? Whether it's planets going around the sun or just that feeling of being pushed to the side of your seat when a car takes a turn really fast, it all comes down to one key principle.
And that principle is called centripetal force. It's basically the inward pulling force that keeps anything moving in a circle. When you spin a fluid, like the water in our glass, every single little particle of water is constantly being pulled towards the center. This constant pulling and turning is what sets the whole stage for our gravity trick.
Okay, let's picture a classic physics experiment, the spinning bucket. When the bucket is just sitting there, the water is perfectly flat. The pressure is the same everywhere. But the moment you start spinning it, what happens? The water gets flung outwards and climbs up the walls, creating that classic U shape, right? Well, that simple action creates a huge difference in pressure. Because there's way more water piled up at the edge, the pressure is super high out there, and it's lowest right in the very center. This difference, from high to low pressure, is what we call a pressure gradient. And that gradient, well, that's the engine that's going to drive our artificial gravity.
Now, this pressure gradient isn't just a number on a page, it creates a real physical push. Think about air rushing out of a high-pressure tire. It's the same idea. The fluid pushes anything within it away from the high-pressure edge and towards the low-pressure center. So if you dropped a tiny little bead in that spinning water, it would get pushed inward by this force. And this is what scientists have a really cool name for. They call it an effective gravity. And the strength of this fake gravity, it's not just random, it actually follows a really precise rule. The force you get is the swirl speed squared, divided by the distance from the center. Or to put it simply, the faster you spin the water, the stronger the force. And the force is always going to be most intense right near the middle. Now, this is the basic idea, but to truly mimic gravity, we need something a little more special.
And here's where it gets really interesting, because not just any old spin will do the trick. That simple spinning bucket creates a force, sure, but it doesn't really act like the gravity from a planet. To perfectly mimic that pull, you need a very particular kind of swirl, a secret recipe, if you will.
So yeah, this is the big question, right? If you spin the water like it's a solid disk, like in our bucket, you get one kind of force. But if you want to create something that behaves exactly like Newton's law of universal gravitation, well, you need to spin that fluid in a much more clever, much more elegant way. And here it is, this is the secret recipe. To mimic gravity, you need a swirl where the fluid moves fastest right near the center, and then it slows down the farther away you get. And it can't just slow down randomly, it has to follow this exact mathematical rule you see on screen. In that formula, the g is the gravitational constant, and m, you can think of m as the mass of a make-believe planet at the center of your glass. This exact pattern of slowing down is the magic ingredient that makes all the physics line up perfectly. So here's how it all connects in 3 simple steps. First, you get the fluid swirling with that secret recipe speed. Step 2, that specific motion creates a totally unique pressure field in the water. And then step 3, this is the amazing part. The force that's created by that pressure field, our effective gravity, turns out to be a perfect mathematical match for the real thing.
And this is the incredible payoff. On the left, you've got the formula for the force in our swirling water. On the right, you've got Newton's actual law of gravity. Just look at them. They are identical. They're the same equation. The force in our fluid gets weaker with the square of the distance, just like the real gravity from a planet or a star. It's a perfect match.
Now, don't just take my word for it. The scientific paper itself puts it a bit more formally. It says the pressure field has the same radial dependence as gravity. All that really means is that the force changes with distance in exactly the same way. The physics inside the glass are perfectly reproducing the math of gravity. It's wild.
Okay, this all sounds pretty incredible. But, and this is a really important but, we have to be super clear that this is a mathematical analogy. It's a powerful illusion. It is not actually gravity. So let's take a quick look at the really important differences.
So yeah, we've made a force that follows the exact same rules as gravity. But have we actually bent space-time inside a glass? The answer, of course, is no. And you know what? Understanding why it's not real gravity is just as important as understanding the analogy itself.
So here's the reality check. This illusion has its limits. For starters, the force it creates depends on an object's density. Real gravity pulls on a feather and a bowling ball with the same acceleration. This fluid version doesn't. Second, this entire effect comes from good old-fashioned fluid pressure, not from the actual curvature of space-time like Einstein described. And obviously, you can just stop stirring and boof, the gravity is gone. The bottom line is, this is a brilliant and powerful analogy, an amazing tool for learning, but it's not a new kind of gravity. So if it's not real gravity, you might be asking, why is this so important? Well, this little experiment is actually part of a much bigger and frankly incredibly exciting field of physics that is all about finding the universe in some really unexpected places.
Let me introduce you to the world of analog gravity. This is a whole field of research where physicists use lab systems that they can actually control, like our swirling water or sound waves or even pulses of light, to create working models of cosmic phenomena. They literally build tabletop black holes to study things like Hawking radiation in a setting they can actually poke and prod. How cool is that?
And this research is nowhere near finished. The next big steps for scientists are to figure out how to keep these special swirls stable for longer periods, to track exactly how tiny objects move within them, and even see how this fluid model connects to all those other kinds of analog gravity systems. It's an active, ongoing quest for sure.
Which really just leaves us with one final, fascinating thought to chew on. We've just seen how one of the universe's most epic and powerful forces can be perfectly mirrored in something as simple as swirling water. And it really makes you wonder, doesn't it? What other profound secrets of the cosmos are hiding right under our noses, just waiting for us to look at them in a completely new way?